yesterday we talked about permutations, so today we're going to talk about permutations versus combinations. So permutation, we had order. The order mattered in what we did. In a combination, there doesn't have to be any order. You can select people and it doesn't matter what order you select them in or things that you select them in. So in this case, we have to get rid of all of those different selections that have the same people but in a different order. So we want to select 3 officers from our 25 people. We are selecting a president, a vice president, and a treasurer. So we are arranging the 3 people that we are selecting. So this is a permutation because the order matters. So N, like I said yesterday, represents the total, and R represents the number we're selecting. So we're doing 25 P3. So 13,800. So that would be our total number of ways to arrange a vice president, a president, and a treasurer from a group of 25 people. Now, second part of this would be the committee. Okay, a committee has no order. There's no officers, everybody has the same level, so it's just 3 people. So if we choose Bill, Jill, and Will, it doesn't matter what order we choose them in. We could choose Bill, Jill, and Will, or we could choose Jill, Will, and Bill, or we can choose Jill, Bill, and Will. It doesn't matter, okay? However many groups. It's the same number of it's the same 3 people in all the groups, no matter what order we pick them in. So this is called a combination. Okay, there's no order, there's no need for a specific arrangement. So a combination does the same thing. It's an NCR, uses N, uses R, does the same thing as we do with permutations, but it gets rid of the groups that are repetitive. So N is our total. R is how many people we are choosing. So it's 25C3. So when we go to the calculator, this time we're going to go down to the probability menu, but we're going to go down to number 3 where it says NCR. So we're going to choose number 3, and we're going to put in 3 people, and that gives us a total of 2,300. So big difference between 13,800 and 2,300. 2,300. Big difference. So lots of combinations that were the same. Okay, moving on to the next page. Kind of sum up what we just talked about. We said that when you're counting how many ways there are to arrange some number of items, the order is going to matter. And we call this a permutation. Now, when you're counting how many ways there are to simply group some number of items, then the order does not matter. And that is a combination. Now, One thing that you want to pay attention to when we're talking the difference between combination and permutation is the fact that is the order making a difference. So when you're talking combination, that would be like players on a team, a committee, but a permutation would be positions that the players take, or officers in a club, those kind of things. So you want to pay attention to the words and kind of use your common sense. Does it make a difference if the order is different? Okay, so the debate club wants to elect 4 officers from 30 members, the president, vice president, secretary, and treasurer. So 30 members is our N, and 4 officers would be our R. And since we are selecting officers, that means that the order matters. So that's the first thing you want to ask yourself. Does the order make a difference? In this case, yes. So we're doing a permutation. Now, that means 30 people selected 4 at a time. So 30 permutation 4 gives us 657,720. So that's 657,720 ways to arrange 4 officers from a group of 30, from a club of 30. Okay, what if we want to just select a committee? So again, N is 30, R is 4, and how many committees? So committee means no order. So we're looking at a combination. Now, so 30 combination taken 4 at a time. And 27,405. 27,405. So again, big difference between 657 and 27. So a lot of differences there. Now, when we do combinations with restrictions, there are lots of different ways for these things to have restrictions. So we want to look at a few different types of ideas. First thing, we're looking at total number of committees possible. Okay, so if we're doing a 4-member committee, how many are possible? Well, total number, we have 7 seniors, 9 juniors, and 5 sophomores. So 7 plus 9 plus 5 is going to give us 21 total people. So we have 21 people to choose from, and we're doing 4 members. It's a committee, so we're talking combination. So 21 combination, choose 4. So that's 5,985. Okay. Now our next step asks how many possible committees are there that consist of all sophomores. So this is going to change our total number. So our total number now is just going to be the total number of sophomores. And from that, we know that there were 5 sophomores in the club, in the 5 sophomore members. So we want, out of those 5, we're choosing 4. So we're still choosing 4 for our R. So this is going to be a 5 combination choose 4. Now, for this, if you go in your calculator and do this, you'll end up having um, 5 ways to arrange this committee. So, what is the probability of getting 5 sophomores, or all 4 of them being sophomores? Sorry, 4 choosing. So the probability that all of them are sophomores is going to be 5 for our event, because there's 5 ways to arrange all 4 sophomores, out of 5,985 ways to arrange 4 people in a committee. So that's our probability. So remember, anytime it says how many, we're just counting. Okay? If it asks for probability, we're doing the fraction, the total of the event over the total possible. And 9 times out of 10, they're going to ask you to put this in decimal form. So 5 divided by 5,985, which gives me, moving this 4 spaces, we'll put 3 zeros in front of that 8. So we're looking at 0.0008 probability for this, or 0.08%. Now, if the club president has to be one of the members. So in this case, we have a restriction that one of our spaces has to be filled by the president. The other 3 spaces can be filled by any other members of the group. So if one space has to be the president, and there's only one person that can be the president, that's a choice of 1. Now, in this group, we have anyone other than the president. So out of the 21 members, we have to subtract the 1 person that is the president, and that gives us a total of 20 people to choose from. So in this combination, we're doing 20 people, and we're only choosing 3 more spaces. So we're looking at 20 combination, choose 3, instead of 21, choose 4. So 20 choose the 3rd one for a combination, choose 3 is 1,140. So that is 1,140. Now, if there is a different number here, because this is a multiplication when we're counting, it's multiplication. So we have a 1 times this. So just remember that if that number was something other than 1, we would actually need to multiply that value to our combination to get our total number of ways to arrange the committee. Okay, so in this case, since it is 1, 1140 is our final answer. Now, last one, how many different committees can be formed if the committee must be exactly 2 seniors and 2 juniors? Well, that means we've separated this into 2 separate combinations. Okay, so they're still being multiplied together, because remember, also and in probability means multiply. So 2 seniors. So we're selecting 2 from our number of seniors, and our seniors in this case, we have 7 seniors, and we're selecting 2 from our juniors, and we have 9 juniors. So we're going to be doing 2 separate combinations here. We're doing a combination of 7 choosing 2 multiplied to a combination of 9 choosing 2. So going into here, we're going to set it up, 7 combination of 2. Make sure that if you have these little boxes like this, that you would put it out of the box before you do the multiplication, and then do 9 combination, choose 2. And once we get that, enter. There are 756 different ways that 2 juniors and 2 sophomores can be on the committee. So that would be 756. So hopefully that gives you enough information to be able to do the lessons for this week. As we said, we're doing permutations and combinations, so hopefully you'll be able to get that done. You guys have a great day.